Well, thank you all, and thank you all for attending this talk. So yeah, I'll be talking about how we can improve our future as mobile Linux users, especially with Mobian, but this all applies to other similar projects such as PostMarketOS and so on. So first question you might have is, who is this guy? Well, basically I'm working as senior software engineer at Collabora. I'm dealing mostly with building and maintaining custom distributions for embedded systems, so kind of related to what I do with Mobian. I've been a long time Floss enthusiast, and I've been a Debian developer for a few years. And back in 2020, so just the last FOSDEM before the pandemic, basically, I got my hands on a Pine phone, and this prompted me to work on that, work on mobile Linux in general, and still continue working on the Mobian project. So what's actually Mobian? It's a Debian derivative, or in Debian jargon we call that a blend, which targets mobile devices such as smartphones and tablets. It has a separate package repository and provides ready-to-use disk images you can flash on a few devices. It's actually a very small overlay on top of Debian, and we only provide currently 25 source packages in our repository compared to the vastly greater number which is in Debian, which means that technically of all the packages you have access from a Mobian device, actually more than 99.9% of that is pure Debian. And so we have a few packages with downstream patches which can't be upstream at the present time. Half of those are kernels, a few others are user space applications, but we're working on dropping those patches and trying to find upstream friendly solutions. We have also a few packages which are basically workarounds because the feature does not exist in the upstream world. Not yet, at least. One of those being, for example, Millipixels, which is the camera application for the Librem 5. Once the Librem 5 gets supported by either or both megapixels and libcamera, we can basically just drop this package and rely on upstream applications. And finally, we have 6 Mobian-specific packages which are to be reworked to be included in Debian itself, so we can lower the impact of Mobian and the footprint of Mobian. So we hope that we can get below 10 packages by the end of next year. We'll see if we make it, but that's our end goal for now. So latest developments, what happened the past year? We had the first stable release. Notice the double quotes around stable. It's basically that we released Mobian Bookworm at the same time as Debian Bookworm was released. So that's our stable release. It doesn't mean it's bug-free. It just means that we don't do huge upgrades and only targeted fixes, so the system stays stable and keeps working as it works currently, even after software updates. So it was released in June last year. We have a few supported devices out of the box, which are several Linux-first devices, the Pine phone, the Pine phone Pro, the Librem 5 also. We support a few Android-based devices thanks to the work of the community, especially on the SDM 845 kernel support. So we support the OnePlus 6, 60, and the Pocophone F1. And we also provide x86 images for desktop PCs or x86 tablets, such as the Microsoft Surface Pro and Go. We provide a single desktop environment in this release, which is FOSH. And we provide also up-to-date 6.1 kernels. So the 6.1 kernel is the not the latest, but the former one, LTS branch, meaning it's supported up until 2026, if my memory is good. And we have a script in CI, which is run daily and automatically rebases all the kernel packages we have on 6.1 on the latest point release. So basically, when there's a security update, usually the day after or the same day, the kernel is up to date in the Bookworm updates repo, which is basically our staging repo for the stable release. There are, however, a few things we wanted to include in this release that couldn't make it. First one is universal images. The plan here will be to have a single kernel package for all supported devices. It's working quite well for SDM845 devices because they share already a single kernel, and the people working on those devices all put their patches into the same repository. But for Pine64 devices, for example, which are based on Allwinner A64, Rockchip, different chips also, it turns out that making a single kernel package out of those proved to be trickier than we anticipated. And so we basically dropped this effort at some point and focused on having just per device kernels, at least for this release. So we couldn't make universal images, obviously. We didn't find the time also to improve the hardware support of upstream. We still carry a lot of patches. I mean, across for all the devices I mentioned, it must be a total of 800 to 1,000 downstream patches in the kernels only. So that's quite a significant amount. We'd like to get them upstream, but we all had day jobs, and for now, every day is still 24 hours only. So we have to make choice. Also, we wanted to switch to the latest LTS kernel, which is now 6.6, and finally realized that we couldn't because we didn't have any time, any resources to spend on that. So that means that Bookworm is stuck forever on 6.1, which is not too bad because the life cycle of Bookworm will end in about a year and a half. And until then, this kernel will still receive security updates and bug fixes. So as long as Bookworm lives, the kernel lives along with it, and we can get up to date and avoid security holes anyway. However, the next release, which I'm about to talk, is Trixie and is already on 6.6. So what about the recent developments? We try still to unify our disk images slowly. Instead of aiming for a single image for all devices, we're taking a step along this path and try to just ship one image per kernel. Until now, we have one image for the PinePhone, one image for the PineTab, another one for the PinePhone Pro and the PineTab 2, and so on. Because some of those devices require highly specific tweaks to be included, be it configuration scripts, UDEV rules, and so on. And so we came to a point where actually most of these tweaks weren't needed anymore because upstream had picked up and had the necessary features for those devices. So we could envision having, instead of having one image per device, having one image per kernel. And so we have our kernels per architecture, basically, per sub-architecture, really. We have one for the Allwinner A64 devices. We have one for the Rockchip-based devices, which are the PinePhone Pro and PineTab 2. Two different socks from Rockchip, but still we can use the same tree, and so on. It was already working well on the SDM845 devices, but we took this step a few weeks ago, and so it quite reduced the number of images we were doing. Regarding Qualcomm-based images, we had until now one image for the SDM845 devices and another one for the SM-S225, which is basically the Fairphone 4, because we used to maintain different kernels for all of those. This is going to change, and actually already changed recently, because we pretty much imported all the patches we needed into a single kernel for all Qualcomm devices we support. So there are not many of those, which is why we're managing to do that. But for now, we have a single kernel which handles all the SDM845 devices, 1+6 and so on, the Fairphone 4, which has a different chip, and also the Fairphone 5, which has another different chip. And so we have a single image for all Qualcomm devices, and we just use a simple config file at build time to generate the boot image for the device, because although the root file system are identical, the boot images are really device specific because they need to have the device tree appended and specific RAM disk and so on. But other than this boot image generation, everything is handled at runtime using Droid Juicer, which fetches the binary firmware from the Android vendor partition, because those devices ship with Android first, and so the firmware are already present on the device. This makes things a bit easier for us because we don't have to care about the firmware license. We don't distribute it. It's at runtime fetched from data which is already available on the device. And there's also a small package which is Qualcomm phone utils, which basically just includes a few scripts and configuration for which are basically the same on all Qualcomm-based devices we support. We're also adding in the process a simpler way to add new device support, at least if it's Qualcomm-based. The thing is, until now, we needed to have a kernel package in the Mobian repo and a few specific tricks in the image build process. We created a new target for this build script and build recipes, basically, which is Qualcomm WIP. It's a kind of a dummy device. But the thing is, you can separately build, or rather cross-compile, your downstream kernel using the bindeb package make target, which is supported by the upstream Linux. So you don't have anything specific to do there. It generates a Debian package which you can drop into the Mobian recipes folder, edit some config file, run the build script, and it will provide you with a rootfs image and the boot image tailored for your device. Then you can flash it, use it fast boot, and hopefully celebrate that your device can run Mobian. It's almost never that easy, but the thing is, we're moving the complexity from knowing the internals of the build system to just debugging the kernel booting on your device. So there's nothing Mobian specific in that. It's just general debugging, and yeah. We basically made it sure it was as simple as it could be from the Mobian side. And we also have a small FOSDEM present, in the sense that Mobian now provides, it's been a week since the first images were published, but we now provide Plasma mobile images. It actually started over a year ago, and the goal was to, from the start, have everything in Debian itself rather than carry downstream packages in Mobian. And so Marco, one of the Mobian developers, worked on that for more than a year, and he managed to get all the needed packages in Debian itself, including the Meta Plasma Mobile Meta package, which you just have to install, apt install Plasma Mobile full, for example, and it will put in all the packages you need. And from there, we could build our Mobian image. So that's basically what happened over the last year. Now what's next? We're trying to take a step further towards universal image. So I've talked about the kernel issue, unifying all patches into a single kernel. But actually, there's all these little device-specific tweaks I mentioned earlier, which have to be handled. And until now, we have per device packages. So that means one new package to have in the repo for each new device we want to support. This is an approach that doesn't scale at all. I mean, it works fine if you manage 10 devices. If you aim for tens or maybe, let's hope, for hundreds of devices, it's just too much work for a small team. So the idea here is to have a runtime service which will identify the device it runs on using the device tree compatible property, for example, or the ACPI, DMI vendor, manufacturer, and so on, strings on x86, select or generate the needed config files, put them into a runtime generated Debian package, and install it on the device, with the ability to place triggers on that so that when one specific config file is modified by another package, this tweaks package is regenerated, rebuilt, and updated as well. So that's something we hope to achieve this year, as well as getting closer to pure blend. This is a specific class of Debian derivatives, and it involves having all the packages into the Debian repository. So this is our next step once we have a working runtime tweaks management. But basically, this would mean having all our meta packages, tweaks packages, and so on into Debian itself. So we can just install everything Mobian from the Debian repos. Not all hardware features will work unless you use the Mobian provided kernels, of course. So Mobian will stay relevant for some time at least. And we'll also be still able to generate ready-to-use images, which will make things easier for users rather than having to build them themselves from the Debian packages. Another big topic is also the call audio management. A few years back, we created CallAudioD, which is a daemon monitoring the phone call status and switching audio profiles and routing on the go, depending on the situation. This was in a Pulse Audio world, and back then Pulse Audio didn't really bother with such things. The only automatic switching it did was when you plug the headphones and so on, and we made sure that CallAudioD disabled that on the Pulse Audio side. But now we're living in a Pipewire world, and with Pipewire comes a session manager, which by default is WirePlumber, and the session manager is meant to do just that, switch audio profiles, switch the routing to match the current situation. And so CallAudioD races with WirePlumber most of the time. It often loses, so this means that you're having a phone call and actually you don't hear anything in the phone earpiece because WirePlumber did the switching right after CallAudioD instructed Pipewire to do so. So there's clearly a conflict there. And the goal here is to make CallAudioD basically a part of WirePlumber itself. This needs some work in Pipewire to make it aware of the modem and to monitor the phone call status. But we hope to submit an initial RFC implementation at some point this year. No promise, obviously. And finally, we plan for a few other minor improvements. I mean, most of the project development process and infrastructure is under-documented, as it is often the case. So we have very user-centric documentation written by users, but we are very few developers and we didn't take the time to do so. So we'd like to improve that because basically a significant portion of the project has a buzz factor of 1, which is me, basically. So I tried to change that and make sure we have backup solutions and we get more welcoming to other contributors. And finally, we'd like also to keep working on upstream device improvements. The PinePhone Pro has a few low-hanging fruits. We can upstream probably easily. The support for the PineTap 2 is being merged upstream as we speak. It now has a working Wi-Fi device. We'll have to look if it can be upstream as well. We hope to support also the PineTap V or PineTap 5, depending on how you see it, which would be the first RIG 5 device supported in Mobian. And and we also welcome, obviously, contributions to support more devices, to help us with documentation, and to basically help us make the mobile future brighter for all of us Linux mobile users. So here are a few links. I put the slides.
Thank you very much. Let's go to the questions.
Hi. So I was profoundly disappointed to read your blog post in October about the travails with the PinePhone kernel and the fact that essentially all of the work that had gone into the PinePhone kernel in Meggie's kernel tree was not being upstreamed, which I presumed was the case, really, since the PinePhone had come along. So I was just kind of wondering what had happened, if anything had changed on that front, if Meggie was upstreaming patches now or anyone else, and kind of what the situation was with that.
For the original PinePhone, the current situation is that someone in Mobian stepped up to maintain and update this kernel. He also started upstreaming a few patches and is monitoring the kernel mailing list and working with upstream to improve the situation over time. So there's lots of work to be done. I know there's also another person which has started working on a driver for the Wi-Fi chip, which for now it was downstream Realtek, full of crap basically, and nothing close to being upstreamable. The new driver will be hopefully upstreamed, and so that's already one big pain in the ass which will be removed. So now there's a bit more hope for the original PinePhone, and if things continue that way, then it will probably be great.
Thank you.
So a question from the Matrix.
Is there any plan to port EG25 Manager to libgpiod 2.0?
Right, yeah, EG25 Manager is a very specific piece of software for the modem found in the PinePhone and PinePhone Pro. It's using GPIO through libgpiod, and there's a new release which changed the API completely. The thing is, for now, libgpiod isn't packaged in Debian, at least the version 2. Version 1 is in Debian. So, yeah, for now, I don't have any definite plan. The plan being, once version 2 is in Debian, then we'll go with it. But before, I'm not sure I have the time to deal with all of this. But merge requests are welcome, as always.
Yeah, so a question regarding your tweaks approach. So why do you want to build, if I understood this correctly, the tweaks on the device, package them there, and then install this package instead of having just one package that carries all the tweaks?
The thing is, we will have one package carrying all the tweaks, but those tweaks can conflict with each other. You can have conflicting configurations for audio, for example, and depending on the device, you have to select the right one. You have also devices which can't suspend because otherwise they don't resume, and other devices which can do that. So you have to select the appropriate tweaks. And the idea of creating a Debian package is that the packaging system is aware of those files. If you have some files under user share something, then it won't override them with a file from another package. If we don't do a package on the device and install it, then if we just move files around, the packaging system will not be aware of those, and if at some point one Debian package ships a file with the exact same name, then it will break. So that's the idea.
All right, please give another big round of applause for Anu.
Thank you.